Hello everyone, this is my in-class exercise 2 demonstration. I'm Khachaturyan Tigran. Here is my ID. Today I'll be demonstrated my microservices architecture project using API gateway, Redis caching and containerized services. Here is my GitLab private repository. As you can see, I have the Docker Composer .yaml file and all four microservices: API gateway, product service, auto service, and inventory service. The processes have been added with report access. So all 11 containers are running successfully. Here you can see the API gateway on port 8080, product service on 8084, auto service on 8082, inventory service on 8083, and all the supporting services including databases and management tools. So I have set up Postman with the API gateway as the best URL variable. So the request goes through the API gateway on ports 8080, not directly to the product service. The product was created successfully through the API gateway. The order request goes through the API gateway. This also goes through the API gateway. So as you can see, all requests are going through the API gateway on port 8080. As you can see, we are not calling the services directly on port 8082, 8083 or 8084. The API gateway routes requests to the appropriate microservice. I'm placing an order for 50 units of SQ for SQ001. So the order was placed through the API gateway. In the order service logs, you can see it received the request and then called the inventory service. In the inventory service logs, you can see it received the call from order service, checked the stock and returned the response. So here is in the database, we can see the order was successfully created. When we place an order through the API gateway, the order service receives the request and then calls the inventory service to check if the product is in stock. You can see in the logs that the inventory service is being called, and based on the response, the order is either created or fails. Here in the database, we can see the order was successfully created. I'm making the first request to get all products. The first request create MongoDB and cached the result in the Redis. You can see the cache key product cache all products was created. The second request used the cache data from the Redis instead of querying MongoDB. Again, notice the cache key still exists and no new keys were created. So the key is product cache all products, and it contains our product list that was cached after the first request. On the first call to get all products, the service queries MongoDB and caches the result in Redis. You can see the cache key product cache all products was created. On the second call, there are no new entries indicating database query because the data is retrieved from Redis cache. In Redis inside, we can see the cache data with key product cache all products. Here is our product in IntelliJ IDEA. Test containers is spinning up for real MongoDB and Redis containers for testing. All tests are passing. These tests uses test containers for PostgreSQL and WireMock to stop the inventory service call. The test is passing. This test also uses test containers to spin up a real PostgreSQL database. All tests are passing as well. So all integration tests use test containers to spin up real database containers. As you can see, the tests are passing, which verifies that our Redis caching works correctly. and our order service can communicate with inventory service, and our inventory service works with PostgreSQL. So, in this project, I learned how to build a microservice architecture with an API gateway that routes all external traffic. I implemented Redis caching to improve performance and used test containers for reliable integration testing. The main challenge was ensuring all services communicate correctly through the API gateway, but it provides a clean separation of concerns and makes the system more maintainable. Thank you for your attention. Goodbye.